Hi, my name is Yuxtanavne, and this is my Week 4, Video 6, Chapter 12, 12.4, Question 8, video assignment. Question 8 gives us the equation f of x equals x squared minus 2x plus 1. It says, use the definition of a derivative to calculate the derivative. First, let's talk about what a definition of a derivative is in order for us to actually begin on this problem. The definition of derivative begins with the limit notation, limit as h approaches 0, f of x plus h minus f of x over h. Now, let's utilize this definition in order to calculate the derivative. We see here that in this above equation, wherever we see an x, we're going to input x plus h. So let's write that. But in order for us to write this equation, we must always keep the same limit notation and continue utilizing it until we actually plug in 0 for h. So let's write it again. Limit as h approaches 0. It turns into, well, our first term is x squared, so that becomes x plus h squared. Then we have minus 2x, so it'd be minus 2 times x plus h, and then just the 1. But then our second term is minus f of x, which becomes minus, and remember, parentheses, we have, well, we know f of x is just equal to this equation. So let's write that out. X squared minus 2x plus 1. And lastly, this is all being divided by h. In order to continue solving this expression, we need to rewrite the limit notation we have here, limit as h approaches 0, and begin to expand and then combine like terms. The first term, x plus h squared, turns into x squared plus 2xh plus h squared. Then we distribute the negative 2 to both these terms, which makes it minus 2x minus 2h. And then simply have the 1. Next, it's very tricky, but remember that this negative sign here is actually going to all three terms inside of the parentheses, making this minus x squared plus 2x minus 1. Again, being divided by h. If we look here, we're going to have some terms that actually cancel each other out. And if your terms cancel out, you know you're doing the problem correctly. First is the negative 1, minus 1, plus 1. Secondly is the plus 2x minus 2x. And lastly, we have the minus x squared and our plus x squared. So let's rewrite this using our limit notation again. Limit as h approaches 0. The problem then turns into 2xh plus h squared minus 2h. How can we then continue to simplify this? Well, we see that the numerator has a common term of h. So let's actually factor out an h. This turns into limit as h approaches 0. Well, the first term becomes 2x because the h goes away. We see, remember, we're factoring out an h, so the h goes outside. The second term has an h squared, so that just becomes plus h. And the last term has an h, cancels out, becomes just minus 2. We have the h in our denominator and the h in our numerator. The h in the numerator is factored out, so the h and the h cancel. And we're left with limit as h approaches 0, 2x plus h minus 2. The final step is to actually plug in 0 for h, which we have one h term, which would then be equal to 2x plus 0 minus 2, meaning that our derivative answer is 2x minus 2. This is our derivative answer. We utilize the definition of the derivative seen here, plugged in our equation, and then solve for the derivative to get our answer. Thank you.